Hi all, RetroTech Chris here again. Today we're going to have a look at my Tandy 1000 TX. I purchased this machine in late 2021 and it arrived in 2022. I've always been excited to own a machine like this. I had an SX growing up and I'm very excited to have this TX in my possession. Today we're going to focus on having a look at performing a series of upgrades to give this machine some pretty cool capabilities. So, without further ado, let's go. So the first component is a 540 megabyte hard drive. I actually was originally looking for a smaller drive for this machine, but the drive that I purchased ended up failing. The original drive that came in this machine is the Maxtor drive that you see here, but unfortunately it was no longer working. Here you can see the hard drive mounted on a hard card, as you will. And what we'll go ahead and do is remove the drive. I've taken the screws out already through the magic of video editing. So let's go ahead and pop that drive off so we can have a look at the controller. And it's particularly interesting to see how the power connector is here. It's a little bit different. And of course the ID connector is standard. Here we can see the Silicon Valley Computer ADP50L adapter, a cool little device. And you can see the name there printed on the board itself, as well as the BIOS revision, which is 218T, the jumper block, the power connector, and then of course the IDE interface connector. Next, we're going to have a look at a Smartwatch Plus, which is a replacement smartwatch made by Derek Osborne. It takes these 1216 cells that you see here. Here's the original chip that was in the system. This is a true Tandy smartwatch. Kind of cool to see it as well. And what I did on daylight savings time this year is to replace the old Tandy smartwatch with the new Derek Osborne Smartwatch Plus. And here you can see it for sale on his store, Cybernetic Systems, for a very reasonable $19.95. Next, let's have a look at an ISA to USB adapter. This is a cool little device. And you can see that this adapter is mounted to a bracket, which I actually designed. More on that in a minute. This adapter is available from AliExpress as well as eBay. I bought mine from Pleasing Store. And you can see all the details here that this is used typically in commercial applications or for enthusiasts like us. And here you can see I'm going to put a 16 gigabyte thumb drive into the system. And yes, with the right driver, this works very well under MS-DOS. What doesn't work is using an adapter like this 3-in-1 or anything fancy. This card does not do fancy. As a part of designing the bracket, I did put two versions on Thingiverse. This is the simpler of the two designs that you see here for ease of printing. And here you can see a model of the original design I came up with that was not as refined. It was based off another model. When I finished the design and tweeted it out, I heard from Sergey. And Sergey was right. My design was not all that refined, and he had a great design that I could base things off of. So here you see that. I took his design and adapted it in OpenSCAD. And here is the result. This is a very nice looking bracket, and I'm very pleased with how it turned out. Here's a couple of designs that I printed out. Here we have the older style on the right, and different iterations of the newer style. I realized I needed to cut out a little bit here in the center, so I did that, and we have another version as well. And the really cool thing about this is I already had Sergey's 8-bit ISA Ethernet adapter, and that's what this design is based upon. So putting these two cards together, you can see the great similarities in the two brackets. Now the first card that I bought did have some problems. For whatever reason, when put in the Tandy, it would cause issues on the memory lines. So I definitely took that card and marked it as bad, as not to use it in any system. And next we have Sergey's 8-bit ISA Ethernet adapter based upon the RTL 8019 AS chipset. It's a beautiful card. And here once again we have a close-up of that nice 3D printed bracket. I love how this card has all of the settings on the back. It makes for easy reference if there's anything that I want to change out. And this card is available on Tandy for a very reasonable $40. And there is a GitHub repository associated with this card. It has a nice picture of the card as well as design information and specifications. A great reference if you want to learn more about the card or perhaps even make your own. So this card does have a boot ROM socket. To me, that meant I needed to put a boot ROM in it. So I went to Amazon and purchased these SST 39S F040 chips that you see here. And if you go to Realtek's website, this is so cool. They have an RPL boot ROM that you can download for this chipset. So I went ahead and did that and navigated to the EXE folder in the download and found the 64K version of the boot ROM. From there, I loaded it up in a hex editor, and since we're flashing this to a 512 kilobyte chip, I copied this several times to fill up the space, since I've seen others like Adrian Black do this in the past. So here you can see me making copies of the ROM image. After saving the image, I verified the size, and it is now 512 kilobytes, which is exactly what we want. So from there, I put one of the chips into my newly acquired TI-866-2 Plus, and I loaded up the software associated with the writer, chose the right manufacturer and model number of chip to write to, and it is an EEPROM, as we can see there. From there, I went ahead and loaded up the image that I created, and you can see that loaded there. And from there, we can scroll through and see the NetWare RPL program for this particular device is available and ready to write to the chip. So from there, I clicked Program and then Program again and sat back for just a few seconds while the device worked its magic, and before too long, the chip was completely programmed. So I went ahead and removed the EEPROM from the writer, as you see me doing here, and installed it onto the network card. You can see me doing that here. Nice and easy to install, piece of cake. And then from there, we now have a boot ROM on this network card. The next thing I wanted to do is expand the TX to 768K, so I purchased these chips on eBay and got them installed. You can see them installed in the TX here, just 4 chips, and it does the job for us. So the next thing I wanted to do was reduce strain on the keyboard cable because the cable is really nice. So I bought this MIDI cable, and from there I used this MIDI cable to act as a keyboard extension since the pinout is the same. It's just a pass-through cable really. So I got it plugged into the keyboard there, as you can see, and you can see just how nice and curly the cable is on this Tandy 1000 keyboard. I didn't want to mess with that, so we installed this nice extension, as you can see here, and we're good to go. The final component that we'll talk about, and I'm really only using this because my Tandy CM11 monitor is downstairs, is this RGB to HDMI. And actually, I'll also be using this to help us capture video today. You can see we have an HDMI cable plugged into a Raspberry Pi with an RGB to HDMI hat. I also installed a power button for ease of powering the device on and off, and a 9-pin extension cable to make plugging in the monitor a snap. Okay, with all of these components identified, it's time to get them installed. We'll start out by removing the 2 case screws so that we can pull the case off of the Tandy, and they're pretty easy to get to, and I might have loosened them a little ahead of time for the magic of video. From there, we can just pull the case cover right off, doing this one-handed so that you can actually see what I'm doing. It slides off nice and easy, as you can see here. It's a cool little design, actually. So from there, I also need to remove this RF shield. It's 2 screws. I apologize, the second one is kind of hidden. I'll show you where that screw hole is here in just a minute. But from there, we can undo those 2 screws and then pop off this RF shield that you see here. And I guess it provides the case some stability as well. And now we get to have a peek inside. First of all, I'll highlight where that screw went in, and you can see that right here. Here we can have a good look at what we can see from the motherboard that's not hidden by the floppy drives. And I'll go ahead and point out the Smartwatch Plus, which is installed there, but could have also been installed under that chip there. And we also have expansion for a coprocessor, though I've not installed one at this time. And once again, while we're here, you can see the chips used for the 768K upgrade right here. Okay, let's go ahead and get the components installed. We'll start with the hard card. These are a little bit heavy and hard to get installed, but we did prevail here. Let's go ahead and get that nice and tightened in so that we'll be all set. And next up, we'll get that ISA to USB installed. So we can go ahead and put that in the slot here. This goes in nice and easy as well. Once again, I'm very pleased with these 3D brackets, and we can go ahead and get that screwed in and nice and secure as well. And next we'll put in the 8-bit ISA network card, and you can see that here. So we'll go ahead and get that installed next to the USB card. I love how they live right next to each other. I think it's just great. We'll get that nice and secured and we'll be all set. So we'll go ahead and get the RF shield installed again. It does take some finagling to get it to slot on the right, as you can see there. Then we can push it down, and we need to move the hard card over just a little bit so that it fits into the opening there. And then finally we can secure it down on the left. As we see, there's a narrow securement over on that side as well. Once in place, it's time to put the 2 screws back in to keep it nice and secure. So we'll go ahead and do that. We'll put the cover back on, and we can go ahead and put the 2 screws in the front as well, so that the system will be nice and put back together with all the components installed. This is exciting and we're all set to go. Let's have a quick look at ports on the back. First we have this AC in that you see here, and next to it we have a printer card. That's right, it is a card edge connector on this particular Tandy 1000. Next to that we have a fully functional serial port, a 9-pin monitor input, and component video and audio. And of course in the expansion bay we have that hard card, the ISA to USB, and the Ethernet card. So I've gone ahead and connected everything up. We'll flip the switch. We can see the memory size in the top of the screen, as well as a floppy drive seek at the bottom of the screen. Nice to see that. We'll now flip over to video capture, and we can see we get a nice splash screen for the hard card BIOS. And then from there we get a nice splash screen for the network card RPL BIOS. We'll go ahead and boot from local disk for the time being, and we'll go ahead and boot with a LAN Manager network. And we can also have a look at the drivers associated with LAN Manager. Notice that we're using an NE2000 driver there on the second line. And the reason that is because this card is NE2000 compatible, despite being an 8-bit card. And here in AutoExec BAT, you can see us loading the UMB program, and all other aspects of LAN Manager I have put in a file called startnet.bat. Okay, let's go ahead and continue through the boot process, and I have sped things up a little bit. Since it takes a little while for the drivers to load, we are loading TCP/IP to have file access over TCP/IP. Once loaded, I can do a directory listing of my Raspberry Pi and see all the data there. So cool. And we can also do a netuse command here, which I'll do in just a second, and you can see that we are indeed mapped to my Raspberry Pi. Next, let's have some fun and do a remote program load. So we're going to do a diskless boot off of a Novell server. We can see it bootstrapping here, and it's actually running DOS 6.22 in the image that it has. It does say booting from drive A, but it actually is booting off of the network. From there, once booted, we can go ahead and log in as supervisor to the Novell server, and we can run the syscon program and see all of the settings for that Novell server. So once this is loaded here, we can go look at the file server information if we like, and see information about this Novell 3.12 file server. How cool is that? We can also go and look at user information, and we'll just pick on supervisor since that's who we're logged in as, and you can see all the options available for that. So fun to be able to do a diskless boot on the Tandy 1000TX. And if you're curious as to what the server setup looks like, I'm just using a virtual machine, but you could use real hardware, and I do have a procedure for setting up this kind of configuration. Next, let's have a look at the smartwatch. To load the current date and time from the smartwatch, on boot up, we can just use this SMW clock space S command, and that will do the trick for us. Now you'll notice that my smartwatch is actually displaying a strange year. I think there's a patched version of this program that displays the date properly, but rest assured the date actually appears correctly in MS-DOS. Next, let's talk about the memory. As noted, I increased the memory size from 640K to 768K. However, if we look at memory in DOS, the total is only 640 kilobytes. What happened to the rest of the memory? Well, the 1000TX takes that additional memory and dedicates it exclusively for video access. So basically what that means is we are going to be limited to 640 kilobytes of memory for our purposes. Now let's have a look at apps and games. And the first one I'm going to load is going to be off of that ISA to USB card using the thumb drive that's attached. The driver for this card is basically one line with some parameters. As far as the settings for the actual driver itself, I'm not going to go into details, but there are some excellent videos on YouTube, especially that top video from Tech Tangents, where Shelby really dives in and shows you exactly which driver to use to get the most compatibility with this card. So let's go ahead and load an application from the thumb drive. I'm going to load up WordPerfect 5.1. You can see the directory listing took a while there. It is a 2 GB partition. So here we can see WordPerfect 5.1 loading, not particularly fast. The access speed on this isn't great, but it does work. So it is cool to see this drive in action. Next, let's go ahead and run Checkit, just for fun to get some benchmarks. The processor installed in the system is an 8 MHz 8286. So we'll benchmark that, and we can see that this is an entry-level system board. Next, we'll benchmark the video and see what we get there, and as well, this is an entry-level display adapter. However, let's go ahead and benchmark the hard disk. And what we will see here is this is a high-performance hard drive, so we get that at least. Next up, we'll go ahead and load Windows 3.0. And I've actually sped things up by a factor of 3 here. We will launch Solitaire and see just how slow the video is. Envision that 3 times slower. Video performance is not great, but we are using a Windows 2.0 video driver here for the Tandy 1000. Next, we can launch Paintbrush, and we can draw just a little bit to show what that looks like. Again, you can see that the graphics are not particularly crisp with this particular mode. This does not make this machine, in my opinion, a great Windows 3.0 machine, but it's cool nonetheless that it will run. So there we have it. We've done a little bit of drawing as well in Paintbrush. So if Windows 3.0 is not the killer app for the system, what is? Well, I would have to say it's probably Deskmate. After all, this is a Tandy. We can go ahead and load up the text application. There's this little README file essentially for video drivers, and we can scroll through it just a little bit. It's not a very sophisticated text editor, but it does get the job done. Kind of neat. We'll go ahead and exit out of that. And now I'm going to load the draw program. And we'll do just a little bit of drawing just for fun. Nothing too fancy, just like we did before. And we can see that this is more than adequate if you want to do some quick drawing. The next thing we're going to explore is PC Link. We're going to run the demo for this. This is so cool. Look at this. We can get online and sharpen our computer skills. And we'll even get a map of the US that shows us where this Tandy online service is available. Look at all of those locations, point to point. Pretty cool. From there we can press enter and we can see the community of PC owners is even in more locations. Kind of strange, but okay. Hey, why not? From there we can run the tour here, and if we have a question about our Tandy, we're going to get all of the support that we need. Let's sharpen those computer skills and get this question about our 1000 TL answered. And we will have it answered within 48 hours from Tandy. We can go ahead and save this question to disk, and 48 hours later, we'll get that response. See you online soon. Next, let's have a look at some games. I love the Tandy graphics and sound. Let's play a quick game of Paku Paku and have a listen. We'll also take a minute and play Lemmings so you can see all of the greatness of Tandy graphics. However, no matter what I did in adjusting volume levels, the sound came out distorted, so I won't torture you with more than a few seconds of sound. So despite the sound distortion, it was cool to see that in action. It's fun to play Lemmings on the Tandy 1000 TX. So in all cases, that's what I had for you today. I hope you enjoyed seeing all the different expansion options that I've put into this 1000 TX, and maybe you have an idea for other things we can do to expand the system. Leave a comment below. Anyway, it's fair to say that I definitely love this little system, and it gets my check of approval. Thanks for watching.